Okay.
Seemed like there was many.
Oh my gosh. Okay, howdy. So today is the last class. So okay, I need to. So this is the last class. So after that, there are no more class, but review session. So review session will be done in the some maybe December 2 or 3, but I will announce it again. And then total average without exam 4 will be released tonight. And also total average, also new grade calculator will be released. So maybe you know that the deadline for QDrop is November 13th. No, sorry, November 30th, not 13th. So yeah, please calculate your total average, and just using the grade calculator, you can just simulate what grade you will get yeah, for on which depends on your exam 4 scores, right? So then you can decide whether you need to QDRAM or not using that grade calculator. So yeah, so it will be released tonight. So if you have any question, please let me know. And lastly, final will be done in December 1st from 8 a.m. to 10:30 a.m. So it is determined by the university policy. And again, like the exam 3, you have 3 options. So one is just using the, uh, what is that? Honorock, using Honorock in eCampus, or using WebAssign with Zoom, or you can use paper version with Zoom proctoring, right? So I will ask you about the email about the which one you do you prefer. Then please send it back to me until the yeah, this Thursday maybe. Oh no, this Thursday is the Thanksgiving. So okay, so next Monday, right? So I will email you about these options. So again, in case of you, if you want to take it in the WebAssign or paper version, then you need to be Zoom proctor as usual. But if you choose Honorock, then you don't need to log into Zoom session, right? And the final actually is not final, but it is exam 4. Okay. So exam 4 contains all multiple choices, I think. So there will not be a, uh, you know, workout part. So everything will be multiple choices or some short answers. But yeah, it's just multiple choice with short answers. So you don't need to worry about the workout part, and also you don't need to take picture or something like that. So just put everything on your WebAssign or on a rack, then you're done. Right? Okay. Ah, yes. So the Kerber, this example covers chapter 13 and chapter 14 and chapter 9. So chapter 13 is about the apportionment. No, not the apportionment. It is just, dividing, fair division. And chapter 14 is about the apportionment. And chapter 9 is about this, voting system. So that's why I call it as exam 4, not final, because it only contains 3 chapters. We dealt with in the last first part of the semester. So uh, yeah, so you only need to study about this. So yeah, it will be divided, but almost the same needs. So maybe just pair division gets 34%, apportionment 33%, voting system 33%. So each almost one third, but maybe it depends on some problems. But okay, great. Okay, do you have any other question? Good. Do you have any other question in Zoom? Or there is some question in chat. So do you know how many people have done the evaluation? Oh, I need to mention that example. Yes, so in the last time I checked that there are 70% of people actually do the evaluation. So as I mentioned, I will definitely drop one oh, lowest quiz score from your one quiz score, which are lowest. yeah, from your total average. So yeah, and will test 4 replace one of our other tests? No. Test 4, exam 4 will not replace any of the tests. So that's why we call it not final, but exam 4, right? Mhm. Yes, yes. So in the current grade calculator, it only counts the dropping one quiz, which are from the extra from quiz one, right? So in the quiz one in video section, I says that if you just submit 2 videos, then I will drop one lowest quiz. And so if you apply this, if you do it did the 2 video submission in the first quiz, then you will get 2 lowest scores are dropped from your quiz. Yeah. Yes. Okay. Yes. So quiz 7 is also added to the grade, and I think that it may not be reflected in grade calculator. Then I will change it again. Thank you. Okay. Okay. Do you have any other question? Good. Yes. So what I released tonight will be the just containing some 2 yellow cells. One yellow cell is just total average I already calculated, and the one other yellow cell is for exam 4. So if you just put your exam 4 score, then you can get the possible total average from the future, right? Because I've heard some comments that current grade calculator is a little bit, you know, complicated to use. So that's why I want to release it again. Okay. Okay. Do you have any other question? Good. Great. Then let's deal with the exam of this chapter 9 of probable voting. So, oh, yeah. So yeah, we learned about a lot of methods, but this approval voting is a little bit different than the others. So in the previous votings, we always assume that there are some, you know, several alternatives here, and you need to decide which one you prefer the most, and which one you prefer the second, and which one you prefer the third. So we just give them ranks on each alternative, right? But in case of this approval voting, you don't have any rank, but you just choose which one is acceptable for you. So each alternative, if you what you choose, are considered as the same rank, right? So it's like the scheduling time with your friends using Doodle poll, right? So did you use Doodle poll? Then there are some other a lot of alternatives here, and just you just ask your friend to choose any of the options which you are possible to make, right? So each that that is called actually approval voting in math. So each voter votes for all candidates they find acceptable or approval, right? So they do not have ranks between candidates, but they just think that this candidate is acceptable or not, right? And the candidate with the most votes, so it doesn't mean that this vote will not be a majority, but candidate with the most votes wins. So votes not necessarily majority. Necessary. So even if there are three candidates here and 10 voters here, but if one candidate gets the full approval voting, then he wins, even if it is not exceeding majors, right? So let's see some example. So here, Pamela is deciding what to serve for dinner on Saturday, and mom draws a list, and the voted are listed below. So mom chooses liver and onions, lamb stew, fish sticks, and hamburgers and spaghetti. So mom thinks that except fried chicken, everything is okay. And dad thinks about the fried chicken, hamburgers, and spaghetti. And boy thinks that lamb stew, fish stick, hamburgers are okay. And first girl thinks that except liver and onion and lamb stew, everything is okay. And girl two prepare hamburgers and spaghetti. So in this case, when you can see that only mom wants to liver and onion as acceptable, so liver and onion got one vote, and lamb stew got two votes, and PC stick got three votes because mom and boy and first girl wants, and fried chicken got two votes because dad and first girl wants, but hamburgers got five votes, and spaghetti got four votes, right? So in this case, so definitive, yeah, my families decide to watch to serve dinner on Saturday and Sunday. So maybe they choose hamburgers for Saturday because hamburger has the most approval. And yeah, if you like to eat the something in the as the two consecutive day, then definitely they've got the hamburgers in twice. But if you're not, then they may choose spaghetti for Sunday, right? So definitely from this, hamburgers and spaghetti are chosen for dinner on Saturday and Sunday, right? Does it make sense? Good. Okay, so to the next example. So a group is deciding to what movie to see, and the votes are listed below. And here, these numbers are just number of voters. So 8 people think that Spectre, Star Wars, and Bridget are okay, but 5 people think that they want to see Star Wars, Joy, and Sisters, and 3 persons think that Spectre, Bridget, Hunger Games uh, they want to see, and the other 3 persons thinks that Joy, Sisters, Hunger Games uh, are the preferable for seeing movie, and only one person thinks that except Star Wars, everything is great. So definitely he's tricky, but anyway, so if you just add total Y for each candidate, then Spectre has 3 votes. Star Wars has, oh no, not 3 votes, sorry. Spectre has 3 Ys, but each Y represents 8 person and 3 person and 1 person here. So it should be 8 plus 3 plus 1, which is 12. So Spectre has 12 votes, and Star Wars has 8 person and 5 person thinks that it is approval. So 8 plus 5, which is 13 persons, thinks that Star Wars is good for seeing. And Bridget has 8, 3, 1 votes. So it has the same votes with the Spectre. And Joey was chosen by 5, 3, 1 persons, which means that 9 persons thinks that Joey is good. And sisters were chosen by as the same as Joey, so it is also chosen by 9. And Hunger Game was chosen by 3 plus 3 plus 1 persons, which is 7 persons. So here Star Wars is the most has the most votes. So definitely Star Wars is choose for their movie, right? So that's the approval voting. Do you have any question? Okay, great. So so here, so we actually saw a lot of voting methods. So, but to choose which voting method is good, we need to give some criteria that these voting methods doesn't violate a rule, which seems reasonable, right? And first criteria for fairness, in this case, is called majority criterion. So which means that if a candidate receives a majority of the first place vote, then the candidate should be declared the winner, right? So which means that if there is some candidate who got the majority vote on the first place or first round, then definitely that candidate is chosen by majority of the people. So definitely we need to choose that major one as a winner, right? So it seems quite reasonable, right? So think about the case example 5.2. So, so it seems reasonable, but there was a lot of voting method which doesn't satisfy this majority criteria. So you can see it on the example 5.2. So here, using the majority winner system, you can see that X was chosen by 16% and Y was chosen by 8% and G was chosen by 7%. And if you add all those voters, then it is 16 plus 8 plus 7. So it has 31. So the majority means that it is just greater than or equal to half of the all voters, which is 15.5. So definitely from here, X has the 16 votes, which exceeds 15.5. So the majority winner is X. Does it make sense? Good. Okay. So then if you use voter count determine the winner, then in the first place, there are 16 persons who thinks that X is the first rank. So you need to get multiply 2 points for 16 to get X as 32 points in the first place. But in the second place, there are no voters who thinks that X is the second rank, so it is 0. And there are 15 voters thinks that X is the third rank, but you know that third rank we just multiply 0, so you don't need to calculate anything on third place. So you need to calculate about first place and the second place. So in this case, total points X will get is 32. And likewise, Y will get 8 voters thinks that Y is in the first place. So Y got 16 points in the first place. And from the first row and second row, you can see that Y is in the second row. So here, okay, 16 plus 7, people think that Y is in the second rank. So which means that Y gets 23 points on second place. So Y got 39 points in total. And for G, actually G is first place for third row. So G got 7 points in the first rank. So G got 14 points from the first rank. And G is in the second rank for the second column. So in this case, G got 8 points from the second column. So G got 8 points. So if you add 14 plus 8, then you got 22 points, right? So here, Y got the most votes, right? So 39 is definitely greatest among all other votes. So in case of voter count, the winner is Y. Okay, does it make sense? So do you have any question? Good. Okay. Then here, think about it. So in the first place, X definitely gets the majority of votes, right? However, in the voter count, if we counting all those ranks in the second or third, then voter count thinks that Y is most preferable than X, right? So in the viewpoint of majority criterion, voter count is not fair because it violates the majority criterion. So no, since product count may violate the majority criterion like the right. Okay. Do you have any question? Mm.
The last one uses both the first one and the second one, but wins like with high number the third. Does he still win or no?
Could you repeat again,
For
please?
example, let's say you got like the three things there. What if the last one loses the two,
Yes.
the first and second, but wins with the big number at the end?
Mm.
Does he still win?
So it is the case that the so you mean that the number of the G change it?
Like, not paying attention to this guy. Let's say
Mhm.
the last one, the last point counts like for 100, and he win, and he gets like 100.
Mhm.
So will he win or no?
Yeah. So if someone counts the hundreds in the last point, then he will win because 100 is the majority one, right? So yes. So what he says about that, if the another candidate has the, for example, 100 points, or for example, 40 points even, yeah, he will win because 40 is just greatest among all other points. Does it make sense? Good. Great. Okay. Do you have any other question? Okay, so that's the criterion. So even if this major criterion seems reasonable, but border count may not, satisfy this condition. And next condition is about the Condorcet criterion. So this means that if a candidate is favored when compared one-to-one with every other candidate, then that candidate should be declared the winner, right? So which means that if you think about the alternatives, and there are some alternatives which exceeds every other alternative in one-to-one, then we need to choose that alternative as the winner, right? So this is called Condorcet criterion because that's what we did in Condorcet method, right? But sometimes this criterion was violated in other methods. So let's see some example. So in example 5.4, so here we have some preference list and we need to find Condorcet winner first. So in the case first with A over B, and this is for A is greater than B, and this is for B is greater than A. Then in the first preference list, A is preferred to B, and second one also A is preferred to B. But for third and fourth one, B is preferred to A, and fifth one also B is preferred to A. So here, 120 and 100 persons thinks that A is better than B. So 220 persons thinks that prefer A to B, but 90 plus 80 plus 45, which is 215 persons thinks that B is preferred to A, right? So 215 is less than 220, so the winner is A, right? And like in case of A and C, you can see that, okay, the first row, first column is for A. People think A is better than C, and second column is for people think C is better than A. Then you can see that actually first preference group thinks that A is better than C, and second one also thinks that A is better than C. but all other groups thinks that C is better than A, right? So here you can add the same number to get 220 and 215. So here A is still winning, right? In the next case, however, if you think about the preference where A beats the D, then first of all, in the first column, D beats A, which means D is preferred to A. But in the second column, A is preferred to D. But also in third column, A is preferred to D. And in the fifth column, A is preferred to D. But for first column and fourth column, voters are preferred D to A. So in this case, the persons who prefer A to B is 100 plus 90 plus 45, which is 235% thinks that A is better than big D, but 112 plus 80, which is 200% thinks that D is better than A. So in this case, again, winner is A, right? So yeah, without calculating the other lines, you can see that actually A beats every other candidate, right? So in the Condorcet test, Condorcet winner should be A because A beats every other alternate, other candidate. Mhm. Mm. Yes. Yes. So in case of Condorcet winner, you need to count at least all possibility that one candidate beats every other candidate. If that is true, then you don't need to calculate not calculate another things, right? Because it already one. Yes, for in case of the in this case we have 4 candidates, but we A, B, C, D, but we already thinks observes that A beats every C, D, B, C, D, right? Then we don't need to calculate another. So in case we have 5 candidates and A, B, C, D, E, and if A beats B, C, D, E, then we don't need to calculate another, bits, right? Does it make sense? Okay. So what Abhi would say is that, yeah, if you just watch that one candidate beats or another, then you don't need to calculate the others because already the Condorcet winner is chosen by the winner who beats every other candidate, right?
Let's say we have 4 and the 4 lose in one game.
Yes. So in any example of Condorcet table, it's any table related to Condorcet winner, only one winners are here. So every others are just.
How about 0? Let's say everyone loses in a way. Can it be 0 winners or no?
Yeah, if there is only, if there is no zero winner, always in Condorcet test, we have only one winner. Or we don't have any winner. Because yeah, if A prefer B, but B prefer C, but C prefer A, so kind of circling. Yeah, good. Great. Do you have any other question? So then we can choose about this priority winner. So this table is just same table we have here, but to get the priority winner, we can see that actually first group thinks that D is the most preferable option. So D has 112 voters. And second group thinks that A is the most preferred option, so A has 100 voters. And third group thinks that B is the most preferred option, so B has 90 voters. And fourth group thinks that C is the most preferred option, so C has 80 votes. And last group also thinks that C has the most preferred option, so C total has 125 votes. So if you just compare all the number, then you can see the priority winner should be C because C gets the most vote, right? But this doesn't mean that C is majority winner because, to be the majority winner, C gets not only the most votes, but the number of votes for C should exceed the majority, which means just half of the all voters. But here, just number of all voters is just 112 plus 100 plus 90 plus 80 plus 45. And if you add all those numbers, then it should be 330, 435. That's 335. 435. So majority should be exceed the half of these all voters, which is half of this 435, which is 217.5. But you can see that C got 125 votes, which is definitely smaller than 217. So there is no majority winners. No, since the number of votes for C does not exceed 217.5, which is just majority of, half of the voters. Right? Do you have any question? Okay, then if you just use the hair method, so here, first of all, you can just compare each one by uh, first round. So in the first round is nothing but just the same as priority voting, right? So here, what you can see is that A got 100 votes and B got 90 votes. C got 125 votes and D got 120 votes. So B has the fewest votes. So B should be eliminated in the second round. And eliminating means that we just delete B in their rank preference list, right? So in the second round, what we have is DAC. So I just write down it here. And AC deleting B and D. And deleting B, C, A, D. Okay. I need a little bit bigger. And C, deleting B, D, A. And again, C, deleting B, A, D. So that's the table we use for second round. So here you can see that Actually, D is preferable for the first one in 120 people. So D still got 120 votes. And A was preferable for 100% only. So A got 100 points. But for all remaining preference lists, C got the first rank, right? If you just eliminate B, then C got the first rank for all three preference lists in the ROS. So C got 90 plus 80 plus 45 votes, which is 215 votes, right? So here the purest votes is for A, so we need to eliminate A in the third round, and B was already eliminated. So we need to just compare C and D, and then in the third round, you have the same table. This is for second round. In the third round, you get D and deleting A and B and C, and deleting A, C, deleting B, D, and deleting B and C, deleting A, D, C, and deleting B, D, deleting A, and C, deleting B, deleting A, and D, and the numbers are just same. Then you can see that the so there are second column, third column, and fourth column, and last column thinks that C is better than D, but only first column thinks that D is better than C. So D gets 112 votes, but C gets all the remaining ones, so which is 100 plus 90 plus 80 plus 45. So here it gets 315 votes, so which gives you majority one. So in the Hare method, the winner is C. Does it make sense? Or do you have any question? Good. Good. Okay, and lastly, you can also do the same thing for border count. So here to use border count, first place gets 2 points, 3 points because there are 4 options. And second place get 2 points, and third place get 1 point, and fourth place get no point, right? So that's why we have only 3 columns. So here, A was second place in the first preference list. So A got 112 in the second place. And for the second preference list, A is in the first rank, so add 100 for first place. And in the third one, A got the 3 place, yes. Mm-hmm. Oh, so in the previous case, it is 210 because there are 4 candidates, 3 candidates. Because in the previous case, if you see this, we have X, Y, Z, only 3 candidates, right? So, but in case of 3 candidates, first place gets 2 points, second place gets 1 point, and third place gets 0 point. But in case of 4 candidates, we have 3 points for first place and 2 points for second place, and so on. And if you have n, n candidates in here, then first place get n minus 1 point, second place get n minus 2 points, and so on. Does it make sense? Great. Good. So yeah, so here again, so let's go back to this example. And in the third preference list, age in the third place. So you can add 90 for third place. And first preference list, age in the first place, but we don't need to count first place because that's the last place. And in the uh, last preference list, age in the third place, so you need to add 45 for third place. And if you just adding all those number by multiplying each point, then A got 300 points from the first place and 214 points from the second place and 135 points on the third place. So total A got 675 points. And you can do the same thing for other ones. So for example, B is third place in the first preference list. So we need to add 120 in the third place. And again, B is in the third place in the second preference list. So you need to add 100 on third place. And in the third preference list, B is in the top. So you need to add 90 to the first place. And in the first preference list, B is in the second place. So add 80 per second place. And in the last one, again, B is in the second place. So add 45 on the second place. And you can multiply all those points to get these 270 points for first place and 250 points for second place. And 220 points on the third place. So if you add all the number, then what you can get is 740. And likewise, in the first preference list, C is in the last, so you don't need to count C for first one. But in the second preference list, C is in the second, so you need to count C as a second place for 100. And again, in the third preference list, C is on the second, so add 90 per second place. And in the for the or remaining preference list, C is on the first, so you need to add 80 plus 45 on the first place. Then if you calculate those numbers, it is 375 for first place and 380 second place and zero, I think it should be zero. Yeah, zero. So if you add those numbers, then it should be 755. Right? And lastly, for D, yeah, D is first rank on the first choice. So 120 was counted for first place. And D is last rank for the three preference lists except the first one. So we don't need to count D on those cases. And D was in the third place on the first one. So we need to add 80 in here. So you get 360 points from first place, 0 point on second place, but 80 points on the third place. So it should be 440. So from this, you can see that in the board account, C is winner, right? Because C gets the most points. Does it make sense, or do you have any question? Good. Good. Okay. Then you can ask which of the method failed to meet the Condorcet criterion in this example. So definitely Condorcet method, we definitely, thinks that Condorcet criterion was met, but probability winner doesn't meet the Condorcet criterion because A beats every other candidate in 1-to-1, but in the probability winner, C wins, right? And also majority voting does not meet Condorcet criterion because even if A beats all other candidates in 1-to-1, but majority winner doesn't conclude that A is the winner. And in the Hare method, again, C was chosen as a winner, not A. And in the border count, C was chosen as a winner, not A, right? So in this case, yep, you can see the border count, Hare method, majority voting, or plurality voting does not meet Condorcet criterion. Doesn't meet the Condorcet criterion. Okay. Does it make sense? Border count. Hare method. Oh, yeah, Hare. Sorry. And majority voting. Good. Okay. Do you have any other question? So if you see this example, then maybe Condorcet method seems the best among all others because border count actually pays to meet the majority criterion, and all other methods also except the Condorcet method fails to meet the Condorcet criterion. But we need to think about the another fairness criterion, which is called monotonicity criterion. So which means that, so think about that, yeah, for example, think about this 2020 election. So everybody knows that Biden was officially win at this point. So, but for example, think about this Georgia, because in the Georgia, they recount their votes because Biden's winning is so close to Trump's vote, right? So, for example, but without Georgia, if we just count Pennsylvania, then still Biden wins, right? But in the reality, Georgia already recounted and thinks that Biden is still win. But think about the actual, the alternative. Imagine that in Georgia, Biden is not win. But without Georgia, Biden still gets the majority of the votes. So the system, the result does not change even whether Georgia is changed or not, right? So that kind of thing is called monotonicity criterion, which means that if you think that candidate A already won the elections, but some of the people change their mind, which is from the Trump to other ones, Trump to Biden, or Trump to George Jorgensen, or any other things. But some people who actually think about the voting to the some defeated one to change their mind to vote the another, or recount it to another to the major one. And then still the winner still be kept in such a situation because in that case winner definitely gets more votes than before, so winner should be kept, right? So that's called monotonicity criterion. So it means that if some voters change their mind from their voting from the loser to the winner, then the winner still wins. A winner should be still winning because winner will get much more votes than before, right? So it seems natural, but sometimes this criterion was not met. So let's see some example why this criterion has the problem. So think about this example 5.6. So IOC was voting for the Winter Olympic. So we have such a preference list for TSQ, where Q for Quebec, Salt Lake City for L, and T for Östersund, and S for Sion. So in that case, you can use the Hare method first to determine winner from day one. And in the Hare method, first of all, in the first preference list things that and first preference list things that T is the most preferable city. So T will get 21 plus, and the last one also. So T will get 21 plus 6, which is 33 points. And second preference list thinks that L is the most preferable city. So I get 24 votes in the first round. And only 30 voters thinks that Quebec is the most preferred city among all. So Quebec will get 30 points and Zion will get no points, right? So in this case, S is the purest, S has the purest vote, so S should be eliminated in the second round. And then you can actually deleting S by thinking about, deleting S for each preference list. Then in the second round, actually T is prepared for, again, first column and first column and fifth column. So T will still get the same number, which is 33 points. But L is also preferable for the second column. So L will get 24 points as with the first round. And Q will have 30 points as he did in the first round. So still, so in this case, L is the option which got the purest vote, right? So we need to eliminate our L. And S is already eliminated. So just delete L from all the options. Then delete L, delete L, delete L, delete L, right? Then you can see that T is preferable for again first and fourth and fifth. So it is 21 plus 6, which is 33. But now voters in the L actually choose Q is most preferable than T. So here the Q will get 30 plus 24, which is 54 points. So definitely Q wins, right?
For the votes on Professor?
Yes.
For the votes in the second round, why does it go down? Why would it not be 42?
Voters in the second round, why would it not be 42 for T, you mean?
Okay, never mind.
So yeah, so okay, so in the voters in second round, we already delete the Q. So okay, I will just draw it again.
Sorry, no, it's okay. I looked ahead and I was working ahead and I forgot. Sorry.
Okay, got it. Thank you. Okay, do you have any other question? Good. So here, Hare method means that Q is the winner. But that night, in number B, 12 people who prefer TQSL, which is from here, TQSL here, and TSLQ, which is here. So 12 people in those last two preference lists decided to move Q onto the top of their list without changing any other preference, which means that they just want to move their Q onto the top of their list, right? So their changed preference list should be QTSL and QTSL, right? Because Q is in the top and the other preference is not changing. So that's the case where voters changing their minds, right? And then you can do the same thing on Hare method to determine the winner from day 2. And in the simple, intuition is that here we know that in the Hare method, Q wins, right? So definitely people in those last preference change their minds that Q is most preferable among all others, right? And all other people does not change their mind. So in that case, intuitively, you can think that Q is still winning, right? Even if they're changing. But let's check it using Hare method. So in this case, again, here T was preferable for first group. So T will get 21 votes. But L was preferable for the second group. So L gets 24 votes. And now Q was preferable for third, fourth, and fifth group. So now Q will have 30 plus 6 groups, which is 42 voters. And S still gets 0. So S should be eliminated in the first round. So let's delete S from the table. Then again, you can see that T still get 21 votes and L will get 24 votes and Q will get 42 votes because their first rank was not changed, right? So in this case, now instead of L, S should be eliminated. Sorry, T should be eliminated because S was already eliminated. And S was already eliminated. So we need to just consider between L and Q. So delete your T in here. Delete your T for all other candidates. Then in the third round, Q still get 42 votes, but the voters in the first preference list actually prefer L to Q. So those 21 votes should be counted for L. So it is 24 plus 21. So it should be 35. So in this method, you can see that now L wins the Hare method, right? So even if Q has the majority votes and some other preference will be changed, favor to Q, but winner is changed, right? So that is the example of when monotonicity criterion was not met, right? So in this example, Hare method violated the monotonic criterion? Yes. Hare method violates the monotonicity criterion, right? Okay, do you have any question? this good? Yes. So the criterion seems very, intuitively true, but sometimes it what does not be satisfiable, right? In some method. Okay, then next one is the independence of irrelevant alternatives. So it seems a little bit complicated. It's actually not complicated. So if a candidate would be declared winner, so again, we have some winner from the majority of election. And then we just want to drop one candidate which are not winner from the options, right? And then still, we need to think that the winner was not changed by eliminating some others which are not be a winner, right? So which means that if there are three candidates A, B, C, and A was chosen as a winner by some method, then if we just drop out C or we just drop out B, then still we need to choose A as a winner, right? So that's called independence of irrelevant alternatives because the other candidate does not affect on the result of election, right? But this is also some methods violate this condition. So let's see some example. So there are three candidates and 20 voters with preference listed below. So here, 7 people think that X is the best among all others, and 8 persons thinks that G is the best among all others, and Y is the best among all others for last one. So who would be the winner using Harris method? So in the first round, X will get 7 points, Y will get 5 points, and G will get 8 points, right? So in this method, Y has the purest votes, so Y will be eliminated. And then, actually in the second round votes, X is, now we need to drop Y, so just delete Y from the list. Then here, first preference list and third preference list thinks that X is better than G. So X got 7 plus 5, which is 12 votes, but G only got 8 votes in here. So at last, X wins because X got the majority votes in the second round. Does it make sense? What do you have a question on this? Good. But if you think about just dropping G without changing anything, then in the condition of the irrelevant or independence of irrelevant alternatives, then X should still be win even if we just drop out G, right? But just let's check it using Hare method. So if you just drop out G and no other things are changed, then X only have 7 votes from the first preference list, but all other 2 remaining preference lists thinks that Y is better than X, so Y will get 13 points. So in this case, Y is win, right? So in the Hare method, the condition for independence of irrelevant alternatives will be violated, right? So that's the example. Okay. Do you have any question on this? Okay, then you may ask that, so which method will satisfy all those conditions for fairness, right? But Actually, Kenneth Serro, who is the economist in the 1950s, proved that with 3 or more candidates, yes, so if there are voters more than 3, there does not and cannot ever exist a voting system that always produces winner, satisfying all those fairness conditions we just say, right? So one of the, so some condition actually meet the satisfying majority condition and the condition for irrelevant independence of irrelevant alternatives, then that condition should be violate the Condorcet condition, or if some other condition satisfy 2 of the condition, then the third one will be violated, and so on. So there are no perfect system. So it is still up to politicians and also mathematicians to choose whatever system is good for society, right? So that is called Arrow's impossibility theorem. Okay, do you have any question here? So remember that in the exam, voting system is not, not offered. So which means that you need to know which voting system means which, and you need to know how to calculate the winner from already given the table of the preference list, right? So that's all for today. And thank you very much for taking this class. And I hope that you learned something from this class. And if you have any question, please feel free to let me know. Okay. Thank you. Yes, I will give you a review on, I think that I will give you a review on December 1st, maybe, but I'm not sure. But I think that it is good for you to giving a review, not on the Thanksgiving, but something day which is close to the exam 4, right? So I think December 1 or 2 was for review. Yes, as like in the exam 3, I will just create the exam problems based on the draft of the exam. Then I will give you as a review so that if you just do the review, then you are fine for exam 4, right? Okay. Yes, it will be released on tonight. So what you need to do is just put the total average without exam 4, which I also will give you tonight. And then your expected exam 4 scores, then you can see the result of your grade. Yeah, that's good. Bye. Thank you very much. Thank you. Oh, thank you.
I had a question
Uh-huh.
into commentaries.
Yes.
So you said
Mhm.
for the chapter 13, they're gonna be 34%.
34%, yes, because chapter 13 has already more,
So
examples.
that's not weak. So what's the best way to study for the concepts?
Mhm.
What's the best way you recommend?
So in my recommendation, just solve all the problems. Because I didn't ask usually, I didn't ask sometimes something like what is this or something like that. Instead, I will give you just each situation, then please, divide it fairly, or please make an apportionment or something like that. So just solve all the question in the website. And if you don't know answer, then feel free to contact me to get to know answer. And if you already solve all the problems in the website and also in the lecture note, then do the examples in the textbook. So there are plenty of exercises in the textbook. Then I would usually use the textbook as the source of the exam 4. So definitely it is helpful for you to prepare.
Okay, so that means
Yes. If you do all the homeworks in the chapter 13, 14, and 9, and if you also do all the problems in the lecture note on chapter 13 and 14 and 9, you are definitely good. But if you think that you have, you need more practice, then you can just solve some problems in the homework textbook.
And thank you, Professor. And this will be first class. It's
Great.
5 stars.
Thank you very much. Yeah.
The tip is, an recommendation is that
Mhm.
you answer fast to your students, and that's something student they like. You, that's what the professor said, that
Mhm.
he grades the papers like in less than 2 days, so he can give feedback, and that's you'll be a good professor in the future.
Great. Yeah, I will definitely do it in future, future, I guess.
One day, hopefully,
Mhm.
thanks to God, we'll be colleagues.
You're right. You're right. I hope that you will also be a good teacher. Thanks.
All right,
Thank you
Professor,
very much.
have a great Thanksgiving.
Yeah, great Thanksgiving too. Thank you very much.
Nice to meet you.
Nice to meet you too.
The first professor of Korea.
Oh, okay. Got it.
And that's something unique.
Mhm. Great. Thank you very much. Yeah. Pardon? No, I think I just shared with my cousins. Yeah, so thank you. Bye. Yeah, meet you again in future. Okay, do you have any question in people in the Zoom? Then let's stop the Zoom session. So if you have any question, Rinjit, please let me know about the email.